Hi, my name is Alexander. Welcome back to my channel. In this video, we will speak about filters in .NET Core. Filters provide a mechanism to execute code before or after certain stage in the request processing pipeline. Filters are classes that implement filter interfaces. Each filter interface defines a pair of methods that are invoked before and after a specific stage in the request pipeline. Filters can be categorized into two types, built-in filters and custom filters. Built-in filters are provided by ASP.NET Core and cover common scenarios such as authorization, caching, exception handling. Custom filters are created by developers and can implement any logic that is needed for the application. To create a custom filter, we need to implement one or more filter interfaces such as authorization filter, resource filter, action filter, exception filter, result filter, and override the corresponding methods. Each filter type is executed at a different stage in the filter pipeline. Authorization filters. They run first to determine whether a user is authorized for the current request. Resource filters. They run after the authorization filters and are very useful for caching and performance. Action filters. They run right before and after the action method execution. Result filters. They run before and after the execution of the action method result. Exception filters. They are used to handle exceptions before the response body is populated. In this video, we will use built-in filters, authorize, ResponseCache, and we'll create action filter and use it to create cleaner and reusable code in our web API. We will use the same projects that we created in the previous videos, Angular Authentication and Authorization Part 1 and Angular Authentication and Authorization Part 2, where I have added one additional method, update product. Filters can be applied globally to all actions in the application or selectively to specific controllers or actions using attributes. For example, the authorize attribute, which we apply to the methods in products controller, is a built-in authorization filter that requires the user to be authenticated. In these projects, when we commented authorize attribute of the method, user could get access to this method without authentication and authorization. Let's use another built-in filter, ResponseCache. The ResponseCache attribute, it is another built-in resource filter that sets response caching headers and enables response caching for the action. We apply this attribute to get product list method that we use to get products from different departments of the superstore. Response caching reduces the number of requests a client makes to a web server. Response caching also reduces the amount of work the web server performs to generate a response. The cache control is the primary header field that we use to specify the way response can be cached. It holds directive instructions in both requests and responses that control caching in browser and shared caches. When a cache control header is present in the response, browsers, clients, and proxy servers should honor the headers and comply with them. To enable caching, duration must be set to a positive value, and location must be either any, the default, or client. Locations options of any and client translate into cache control header values of public and private, respectively. If you don't send location, the header accepts the default value any. Response can be cached on either the client side or the server side. Location any, cache control set to public, indicates that client or any intermediate proxy can cache the value, including response caching middleware. We set the response cache duration as 30 seconds. This defines max age in the cache control header. Response caching doesn't store anything on the server, but instead manipulates headers to instruct how to cache responses in web browsers and proxy servers. In our example, we will use vary header. Vary indicates that it can send a cached response only if all the fields that we provide in the header match exactly with the previous request. If any of the fields changes, the server generates a new response. The header is only written when the vary_by_header property is set. The property is set to the vary property's value. The following sample uses the vary_header property. Here we set the value for the vary_by_header property to the user agent, which will use the cached response as long as the request comes from the same client device. Once the client device changes, the user agent value will be different and it will fetch a new response from the server. Another parameter we can use is noStore. This will take precedence over the location value we set. noStore instructs client or proxies not to cache the response. The preceding code requires adding the ResponseCache and middleware services, add ResponseCaching to the service collection, and configures the application to use the middleware with the use ResponseCaching extension method. GetListProduct method we use to get products from different departments of the store. Start application. Put a breakpoint in a getProductList method to test when the client request hits the method. Click Products. The client request hits getProductList method and we receive the list of products from the SQL Server database. Click buttons of other departments. We see that product list appears without hitting getProductList method. It means that product list we receive from the cached response object. But ResponseCache should be implemented carefully. For example, you can update a product in a SQL Server database. But the getProductList method still contains the product list from the cached response, and the updated product will not be updated in the product table until the cached response expires. We several times updated product, but in the table below, the product has the old property value. Comment ResponseCache filter. Now, every time when we update product, its property values are updated in the product list table as well. It is because without ResponseCache filter, every client request hits getProductList method and we receive the products list from the SQL Server database. When we click the buttons to get products list from other departments, every time the client request hits getProductList method, because now the response is not cached anymore. Now we will create custom action filter. In toControllers method, getProduct and updateProduct, we have similar code to get product from the database based on the product ID. We can put this code to ValidateEntityExistsSync filter to make our code cleaner. I have added this filter under the folder Filters. To create action filter, we have to implement iActionFilter interface where we have to implement two methods, onActionExecuting and onActionExecuted. In order to use dependency injection to inject a DBContext class object store context into the filters construction, we will create service filter and use service filter attribute. Service filter implements the inversion of control principle by automating the process of dependency injection and object instantiation. DBContext class is the main class that allows communication with a database using Entity Framework Core. Another requirement to inject store context into the filter using dependency injection is that store context should be registered as a service. This is done in program.cs class. Add code to our filter. We injected store context to our filters constructor. Writing a console notification from every method that method starts. On action executing, we put the code to get product entity item from SQL Server database. From the request getProduct, we get product ID from HTTP parameter object. From the request update product, we get product ID from the stringified product object. Or return bad request object result with the message bad product ID parameter. Based on the product ID, we try to get product from the database. If no product found, we send a response as an instance of not found result. If product found, we save it in HTTP context.item key value collection with the key product and the value products object. Add service filter attribute to get product and update product methods in the product controller. Update the code in the methods. Comment this line. Get product from HTTP context. Comment old code. And add code where we get product from HTTP context. Now we have to register our filter with a lifetime. The lifetime describes how long an object created will be used by the system. In .NET Core, there are three primary lifetimes for the services: singleton, scoped, and transient. Singleton lifetime means that an object will be created once and the same instance will be used throughout the lifetime of the application. This lifetime is useful for the object that needs to be shared across multiple components of the system. Scoped lifetime means that an object will be created once per HTTP request, and the same instance will be used throughout the processing of that request. And transient. Transient lifetime means that a new object will be created every time it is requested. We will use scoped lifetime. Builder services at scoped is a method that registers a filter with a scoped lifetime, which means that a new instance of the filter is created for each request to the application. The instance is then shared within that request and disposed of when the request ends. Compile and test application. Get product. In a console, we have notifications: think before action execution, then action, think after action execution. Update product. We see the same notifications: think before action execution, think after action execution. When update product request finishes, we send additional request get products list to update products table. Synchronous filter works. We can create a synchronous filter as well. Add asynchronous filter. Asynchronous filters define only one on-stage execution async method. For example, on action execution async. In the preceding code, the ValidateEntityExistsAsync filter has the action execution delegate next, which executes the action method. Before next delegate, we put the same code as we created in ValidateEntityExistsSync filter. Command sync filter tag and add async filter tag to the getProduct and updateProduct methods. Register async filter. Start application. Get product. Update product. In a console for the both methods, we see similar notifications. Async before action execution, action, async after action execution. For update method, async before action execution, update action, async after action execution. Asynchronous filter works. That's it what I wanted to show you in this video. If you enjoy this content and would like to see more and support my channel, please feel free to like this video and hit the subscribe button. Thank you for watching, have a good day, and bye!